Hello again, Tom from Every Step Physics, EveryStepCalculus.com. Physics problem, as you can see on your screen, as far as a satellite's altitude above a planet, not the Earth. We can figure that out too, but this happens to be a planet and similar to Jupiter or something. And we've launched a satellite, or they've launched a satellite, and they want to know how high it's going to be around the planet to orbit. So anyways, that's the question in a test. We're going to press get physics into the home entry line and then press enter so you get the main menu of physics. And I'm already at the planets situation here. You can see it here, planets, which is what anything that's involved with satellites or Earth or Jupiter or moons or anything like that is in planets in my menu. Okay, you'd go to planets and press enter, and it gives you the choices for planets. In this case, since we know how to calculate how far above the planet's surface is the satellite, that would mean altitude in physics. And so we're going to choose number 2, and it's another planet besides Earth with the satellite. The altitude is above. I'm going to choose that, and we're going to press enter. I gave you the gravitational constant, which is Newton's idea, 6.67 e to the minus 11. You start writing this on your paper, make a note of that, okay, because it's in the formula. And we're going to put in the period. Now I've put these already into the simulator here, these amounts, so that I can save time doing it. But in your case, you press alpha first. We have to do that in all my programs for entering this first. Any entries into these lines here, you have to push alpha first. Okay, so alpha, and then you put 10.7. Okay, I've already done that. Now remember that. Okay, so, and they say hours. We have to do conversions, and here's the conversion to make it to seconds, which is all in every formula in physics. It's seconds. Okay, generally. So I always ask you, if you've done it right, you can go back and change it in case you made a mistake, but it's okay. We're going to enter the radius of the planet, which is 6.9910 to the 7 meters. I've already done that. You press alpha now first to do that, and then put the numbers in. And number 3 is meters. And then I'd say that's okay. I gave you a chance to change that in case you made a mistake. We're going to enter the mass of the planet that they give you, 2.2 times 10 to the 27 kilograms. I've already done that. We're going to choose number 2, kilograms. See number 2, you can press 2 or scroll up to it. I say it's okay, and then we start to do the problem. Now notice this is the formula. R cubed, which is the radius cube, is equal to the gravitational constant times the mass of the major planet, the big planet, times the period squared, divided by 4 pi squared. Okay, just like that. That's the formula. So we enter all the variables into that formula and work the problem. You write everything you see on this on your paper. Okay, and R is equal to the orbital radius, and is equal to 1.76668 e to the 8 meters. Okay. Now to find the altitude, you have to subtract the radius of the planet from the radius of the orbit. And here's what you entered, and here's what we've figured, and what we've entered into the variables. And it's 1.07 e to the 8 meters, which is what they want in meters here. Now if they wanted kilometers, we would divide by 1,000 and come up with this, e to the 5 kilometers. Okay, pretty neat, huh? EveryStepPhysics.com. Go to my site, buy my programs. I don't see why you wouldn't. Pretty cheap. I think $30 for maybe 400 programs, and to answer your physics problems, just like this, with menus, and the easiest I can figure out how to do it. If you have some other ideas, email me, and I'll certainly do it that way. But to me, this is the only way to do it. And generally in my programs, you go to what's asked for in any written problem, and then you write on the side of the paper the variables that they give you, and you look in my menu for those variables, and then you can solve the problem. Okay. So, anyways, good luck. Have a good one.